Hello dear students, my name is Vikram Nallode. I am from Mechanical Engineering Department and I am working at Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering, Yadra, Isarkanji. In today's lecture of Automobile Engineering, we will focus on unit number 3, Transmission System, in which we will cover universal joint and propeller shaft. So let's start with universal joint. Generally, universal joint allows driving torque to be carried through two shafts that are at an angle with each other, as it is shown in this diagram as well. So these are the two shafts. One is connected with the transmission system, and second goes to the differential gearbox. So as we have discussed, these are at an angle with each other. A simple universal joint of two Y-shaped yokes on one on driving shaft and other on the driven shaft. The four arms of spider are assembled in needle bearing in the two yokes. The driving shaft and yoke force the spider to rotate. The other two triunions of the spider then cause the driven yoke to rotate. When the two shafts are at an angle with each other, the needle bearings permit the yokes to swing around on the triunions with each revolution. A simple universal joint does not transmit the motion uniformly when the shafts are operating at an angle. Because of this, two universal joints are used in a vehicle, one between the gearbox and the propeller shaft and the other between the propeller shaft and differential pinion shaft. So, universal joints simply allow drive shafts to move up and down with the suspension while the shaft is moving, so power can be transmitted. When the drive shaft is not in a straight line between the transmission and drive wheels, rear wheel drive vehicles have universal joints. Universal joints are also called U joints at both ends of the drive shaft. So, as in this picture, it shows the universal joint. A universal joint, it is a particular type of connection between two shafts. So I will focus to demonstrate these are the two shafts here. So uh, it's a particular type of connection between two shafts whose axes are inclined to each other. So about inclination, we can say one axis is like this and second is like this. Means these two shafts are inclined with each other. The most simple type of universal joint is the hook joint, which is most widely used because of the fact that it is simple and compact in construction and reasonably efficient at small angles of propeller shaft movement up and down, say up to 18 degrees. The axis of the shaft, uh, one is like as I already told you, the axis of the shaft, one is linear and second is inclined to first one. So axis, these are intersecting. Each of these shafts contains a yoke. The cross C has four arms. This is the cross C that has four arms in all the four directions. The two opposite arms of the cross are supported in the bushes in the yoke of shaft first, while the other two arms of cross are supported in the yoke of shaft second. Thus, first shaft can have angular rotation about axis, that is vertical axis. So let us consider this is the vertical axis, and the second shaft about the axis in this manner. It is thus seen that it will be possible with the hooks joint for the shafts which are at left and right side, both shafts to have positive drive while allowing angular moment between them. So in second picture in the sense this one. So in this picture, it is clear that it is invented by Gerolamo Cardano in the 16th century. It failed to maintain constant velocity during rotation, was recognized by Robert Hooke in the 17th century itself, who proposed the first constant velocity joint consisting of two Cardan joints offset by 90 degrees so as to cancel out the velocity variation.